Hey guys, so I'm going to work one of those wait time problems that seems to be giving some of us a little bit of a hard time. And remember that because this says that the hold time for callers is normally distributed, that means if you were to lay out all the wait times, it would look like a normal curve. Most of your wait times would be, gathered here around the mean, which in this case is 7.0. So most of them would be clustered around that. And then, of course, you would have wait times that are higher than the mean and some that are lower than the mean. And when you're dealing with a normal curve, a positive z-score involves those numbers that are above the mean, and then a negative z-score reflects those numbers or those values that are below the mean or below the average. So in order to take advantage of the fact that these are normally distributed, and to find the percent of callers who are between 6.1 minutes and 7.8 minutes, we need to convert 6.1 minutes and 7.8 minutes into z-scores. And remember the formula to convert these into z-scores. You take the value and subtract it from the mean. So I'm going to do 6.1, my first value, and I'm going to subtract it from 7.0 because that is my mean, and then I'm going to divide it by my standard deviation. So if I do that, I get negative 0.9 divided by 1. So my negative z-score, or the z-score for 0.61, is negative 0.9. I'm going to do the same thing for 7.8. So again, take the value, subtract the mean from it, divide all of that by the standard deviation. So we get 0.8 divided by 1, which is 0.8. And that makes sense if you think about it, because an amount of time, a wait time that is below the mean should end up with a negative z-score, as well as a time that is above the average should end up with a positive z-score. So now we've got our z-scores. What are we going to do with it? So this is definitely not drawn to scale, but basically what we're trying to do is we're trying to find the percent of callers who fell in between a negative z-score of 0.9 and a positive z-score of 0.8. And we're going to need to use that normal curve table to figure that out. So that's when I need to go to these normal curve tables that are given to us with the question. And page 1 is the one that has the negative z-scores. So I am going to look here. Now remember what this is telling you. This is telling you areas to the left of z. So if I'm looking at my normal curve, here's my z-score. This is telling me the amount of area that's to the left of that z-score. That's going to be very important in a second. So the z-score that I am looking for is negative 0.9. So I'm going to scroll down here to where I find 0.9 here on the table. And the top of the chart is kind of cut off, but if you could see the top, the charts look like this across the top. And they go off across. So since I'm looking for 0.90, I didn't have anything that came after 0.9. I'm going to go right here to this section of the chart under 0, 0. And I'm going to see that 0.1841 is the amount of space to the left of 0.9 on the normal curve. Now I'm going to go to page 2 because that's where the positive z-scores are. Look right up here and I see 0.8. And I'm going to look in this column right here because there weren't any digits that came after 0.8. It's just a plain old 0.8. So you see that I've got the area 0.7881. So now what exactly does that mean? What did I just figure out? So I'm going to draw myself another little normal curve here. So that means that, and again my two z-scores had a positive 0.9 at a negative 0.8. So what we just found from that table was that to the left of 0.9, we had 0.7 0.7881. So all the space to the left of 0.9 was 0.7881, the total area to the left. And then the area to the left of 0.88, or of negative 0.8, again, we just got this from the table, was 0.84, oops, no, it was 0.1841. So in order to find the space that is in between the two of them right here, we need to subtract, we need to take 0.781 and subtract out 0.841 to get this area that's left over in between them. So again, just information we were given from the table, it told us that all the way to the left of the 0.9 was that 0.7881 was the area, and then all the way to the left of the 0.8 was 0.1841. So what we need is the space that is in between them right here. So that is why we are going to subtract. So over here to the side, I'm going to do 0.7881. Take away 0.1841. When I subtract that, I got 0.6040. And remember the way that area works. So this is a decimal. Obviously, we need to convert it into a percent. And so to convert it to a percent, I take my decimal point and I move it over 2 places to the right. So my final answer, what percent fell in between 6.1 minutes and 7.8 minutes, is going to be this expressed as a decimal. I'm sorry, this expressed as a percent, which is 60.40%.